Our next presentation will be delivered by Evgenia Melichova, Identification of Habitats Suitable for Polar Bear Maternity Denning on Wrangel Island, 2001-2020. Evgenia, please, the floor is yours. I would like to share on our experience of modeling habitat suitable for polar bear maternity denning. You know, maternity denning survey is an important part of abundance estimation. Since polar bear lives in the hardly accessible areas, we need to identify the areas that are more suitable for maternity dens of the breeding female polar bears. Most of the polar bear from Alaska and Chukchi population, they belong to Wrangel Island also. Our goal is to identify the optimum maternity denning habitats on Wrangel Island using remote sensing data and matching the changes in the area quality for 2 decades, from 2001 to 2020. For that, we use the modeling of habitat suitability using a deterministic Bayesian network based on remote sensing. And Bayesian network are the systems, the number of variables, and they are linked with the cause and result relations. And we have a conditional probabilities attached to each link. These tables determine probability of the fact that the node will be in a certain condition depending on the condition of the nodes that impact on it. In our case, the outgoing parameter is suitability of habitats expressed by suitability index from 0 to 1. The modeling of suitable habitats looks as follows. In the beginning, based on literature data and using experts' assessment, we determine the requirements of the species to the environmental conditions, and we identify the variables. Then we put together the complaints tables of the environmental variables to suitability of habitats, and then we categorize the variables of the environment in GIS format, and then we convert it into the table form. In this form, data comes to the Bayesian network, and we calculate suitability of habitat. And as a result, we validate these results in terms of quality versus actual data. Then we convert it back into GIS, and let's see this process in more detail as it applies to our task. The major requirement for successful maternity denning on Wrangel Island is presence of snow piles of significant depth, and the distribution is determined by geographic and climatic factors. To build the Bayesian network, we identify two groups of variables: static variables versus and dynamic. The first ones are stable, but the second group is variable: absolute altitude, absolute elevation, and slopeness, steepness, and remoteness from the seashore, coastline. And so the optimum of these parameters, we use it as a basis for the data for the second group. As a dynamic variable, we consider the snow cover. Since we cannot determine the depth of snow cover in different regions of the island, we looked at the dynamics of the snow cover during the autumn time, and we identified the areas where it remained permanently never falling. And we believe the snow is of enough depth. We analyzed the period from the mid-September to the end of October that corresponds to the approximate denning period on Wrangel Island. And the sensitivity analysis of these variables proved that elevation and exposure are not significant. That's why we removed them from the model. They do not have any impact. As input data for static variables, we use global digital elevation model, and for the snow, we use the product based on MODIS data that shows distribution of snow cover during 8 days period. To validate the model, we used the maternity dense location that we received used to satellite tagging with the Fish and Wildlife Service US data. So there are comparison tables in terms of steepness and of the slopes and elevation and the suitability of habitats. So the slope steepness is shown in this format. Still of spatial distribution of the maps of the snow cover is of bigger scales. We generalized the images and brought them to the same resolution, 500 meters. Then we categorized it according to the comparison tables. Here there is an example of GIS layer for the variable snow cover in 2019. We took 6 images reflecting the snow cover across the island over the course of 8 days. We overlapped and put it together, and we identified the areas where snow remained permanently throughout the entire period duration. And in this way, we received images for each and every location. Categorized the GIS layers, we converted in the table format that was used as input parameter in BICS network that represents the combination of nodes, of input nodes and one output node. For validation, we used 12 locations of maternity dense. This is not enough to assess quality of our modeling of the habitats suitable for maternity dense, but still we can validate quality of the model that includes only statistical variables. We build the error metrics where we match modeled and actual data, and the frequency of errors is 17%. And the errors occur due to variance of resolution. We believe that the model is suitable for our task. The final result is shown in the table, which is converted back in the image, and this is the distribution scheme suitable for location suitable for maternity and habitats that are classified by suitability degree. Modeling was done for 20 input data sets from 2001 to 2020. The share of suitable habitats is from 2 to 43% across the entire island territory. In most of the cases, this is 6 to 8%. The maximum value is for 2002 when we had a stable cover, and it started to be formed in the mid of August. The average September and October temperatures, and they were minimum over the course of all the period of observation, minus 15 to 20 degrees Celsius. The minimum suitability area was registered in 2010 and 2016. During these years, the snow cover started to be formed since mid-September, and we have positive temperatures in September. No patterns is identified, and over the course of 3 recent years, we see the reduction of suitable area, but we cannot show for certain that this is a trend. And most of the habitats suitable for denning and of lowest quality, and this is related to the fact that the island is a flat surface and with less probability to form the suitable maternity dense. For each analyzed year, we identified a pattern that the lower quality of habitats, the lower share of them we have in actuals. And we combine the results of each and every year to take a look at the distribution for maternity denning areas that are most suitable, with suitability index from 0.5 to 1. Just a few such areas were identified. Most of them tend to be in the vicinity of the mountains, western Bezimyanny Mountains, central mountains, western plateau, and Mineyev Mountains and eastern plateau. And we didn't include such well-known denning areas, green hat and variant. Probably this is related to the fact that during different years, snow accumulates in different areas, and that's why, as we put together data from different years, we did not arrive on a stable site of snow accumulation. Results can be applied to define the optimum research areas and routes for spring surveys, and so the scale is not very high, and we cannot use it for highly accurate location, but still we can identify the areas for survey. And we will continue our work. We will calibrate new locations once we want to extend the model, adding new variables, and build the scheme in a better scale for specific areas, and develop biases network based on autumn surveys of polar bears done in 2016 and 2020. Thanks for your attention. Thank you, Evgenia. We still have 1.5 minutes. If you have a question, please ask it. There are two questions, one comment and one question. Natalia Kryukova said it's a really fascinating presentation, and then a question from Vladimir Gromov. Thank you for your interesting talk. Here comes a question. Have you modeled the low-level scarce snow winter? Which percentage of accessible locations for the maternity dens will be accessible in case of scarce snow amount? We never considered it. Thank you, Evgenia.